Hello everyone. This video is about mass and weight. You know what? Most of us think that mass and weight are pretty much the same thing. Are they? No, they are not. What if somebody questions you, what's your weight? What do you answer? 50 kg? 30 kg? Or 40 kgs? Your answer is in kgs, right? If you also have this confusion, what do weighing machines measure for? Or what do they tell you? Is it mass or is it weight? Welcome to Learning with Madam. In today's video, I will tell you the exact difference between mass and weight. Also, we will discuss everything about weight, how the weight varies at different places. Mass, what does it mean? The total quantity of matter contained in an object is called mass of an object. So, mass is actually the quantity of matter contained in a body. It is measured in kg. Kg is the kilogram. For example, 2 kilogram of rice. In our easy language, we say it as 2 kilogram, but actually, it is the quantity of matter contained in that. So, inside is the matter. How much is the quantity? That is the mass. The total quantity of matter is called mass. Is called as the mass. Alright. Weight. What does it mean? The gravitational force by which Earth attracts an object is called weight of the object. So, weight is the force of attraction between Earth and the body or the planet. It could be right between any planet or any heavenly body and the masses. So, the force with which an object is attracted towards the center of the Earth is called the weight of the object. Mass does not depend on g. Your mass, it is a total quantity of matter in you, right? So mass, it does not depend on g, which means it does not depend on acceleration due to gravity, but weight depends on acceleration due to gravity. Why weight depends on g? Because weight equals to mass into acceleration due to gravity. How come it is weight equals to mass into acceleration due to gravity? Look, we already know force equals to mass into acceleration. Force equals to mass into acceleration. In case of Earth, A equals to g. In the place of A, we will be writing g, that is F equals to mass into acceleration due to gravity. But the force of attraction of Earth on an object is called its weight. So if we consider the weight of an object to be W, we can rewrite this equation as, here W is the weight. So we can rewrite this equation as weight equals to mass into acceleration due to gravity. So weight is the force. We call force as a weight. That's why weight depends on acceleration due to gravity. Because weight equals to mass into acceleration due to gravity. Mass of an object can be measured by its inertia. We have learned that the property of an object because of which it resists to get disturbed its state is called inertia. We have also learned that the greater the mass, the greater is the inertia. Here weight equals to mass into acceleration. Here fourth point is mass of the object remains constant at all the places. Yeah, definitely it remains the same whether the object is on the earth, the moon or even in outer space. The mass of an object is constant and does not change from place to place. While weight of the object is different at different places. Weight is different at different places as it depends upon g, and it is different at different places or planets. So it doesn't matter if it is another place or another planet. Weight is different at different places. Right? Now, SI unit of mass is a kilogram. So mass SI unit is in kilogram, while weight being force as the SI unit of force, which is Newton. SI unit of weight is Newton. Mass is a scalar quantity, weight is a vector quantity. You know what? Mass can never be equal to 0. Mass does not change even the value of g is 0 at any place. Here g is the acceleration due to gravity. So even the acceleration due to gravity is 0 at any place. The mass does not change. For example, if you take a feather, a weightless feather, it also has a mass. It won't be 0. Mass can never be equal to 0. While weight can be equal to 0. Weight of the object becomes 0 if g is 0. If acceleration due to gravity is 0, the weight of the object will also become 0. Measurement of mass is done by using a pan or beam balance. So a pan or beam balance. A beam balance is a weighing instrument that uses lever and pans to measure the weight or mass of an object. Here beam is a horizontal leaf with two equal arms called the beam or iron, and two weighing pans suspended from the ends of the beam. Also a pointer is fixed to the center of the loop that supports the beam. Standard weights used to balance the beam. So to measure the mass of an object, you place the object on one pan and add weights to the other pan until the beam is level and the pointer is vertical. Total weight of the weights is the mass of the object. Also, there are different types of beam balances including double pan balance, single pan balance, and etc. Measurement of weight is done by using a spring balance. A spring balance. Spring balance. But first, let's define the term spring scale. The spring scale means a tool for measuring weight or force. Also, it is known as spring balance or Newton meter. This device is used primarily to weight items or objects by attaching them to a hook at the bottom of the device. Yes, it consists of a spring fixed at one end with a hook to attach an object at the other. So this device is used to weight objects by attaching them to a hook at the bottom of the device. So this was the difference between mass and weight. Alright. Okay, let's understand this. Let's discuss weight on the moon. The acceleration due to gravity on moon is g. G equals to g by 6. It means weight will be weight of the earth divided by 6. So if g is 1 by 6, then weight will also be 1 by 6. So we can say that the gravity on moon is 6 times weaker, right? Look, what I want to tell you is the weight of an object on moon is 1/6 of its weight on earth because the moon's gravitational force is 1/6 of earth. The moon's mass and radius are smaller than earth, which means that the moon's gravitational force is weaker. From this we can conclude that the gravity on moon is 6 times weaker. Now let's solve the problem. The maximum mass that Arun can lift on earth is 30 kg. What will be the maximum mass he can lift on the moon? So the maximum mass he can lift on earth is 30 kg. We have to find the maximum mass he can lift on the moon. So we have to find the maximum mass Arun can lift on the moon. So I told you Arun has the same amount of force he can apply on the earth. I mean how much force he is applying on the earth. He is applying force which is the weight of the body. Weight is equals to 30 into GE. G of earth, alright. GE is the G of earth. When he goes to the moon, he can lift the same force. He is applying force which is 30 into GE, and it will be equal to how much mass he can lift. Here mass multiplied by acceleration due to gravity on the moon. 30 into GE equals to mass into acceleration due to gravity on the moon. Look what I have done. I have equated the force. The force he can apply on Earth is equal to the force he can apply on Moon. Correct? Okay. Now we have to see that the force he is applying is equal to how much of the weight. What is weight? Weight equals to mass into acceleration due to gravity. How much is the acceleration due to gravity? Here 30 into GE is equals to mass into GE by 6. Because G of Moon is equals to 1 by 6 of G of Earth. Here GE is cancelled. Mass will be 30 into 6. That is equals to 180 kg. So on Moon, Arun can lift, the maximum mass is 180 kilogram. So the maximum mass that Arun can lift on the Moon is 180 kilograms. Always remember the gravity is more. On the Earth the gravity is more, means you can lift a small mass. But because you have the much force, that much force will be equal to greater mass on Moon. Similarly, the gravitational pull exerted by the Moon is smaller than the gravitational force exerted by the Earth when the same object is on the Moon. As a result, the object's weight lowers, as the acceleration due to gravity on the Moon is about 1/6 of that on the Earth. Now, let's solve some fast problem solving. Let's make it quick. So the question is, what is weight? What is the weight of a steel ball of mass 1 kilogram? We already know weight is the force of attraction on the body due to Earth. Now we want to find the weight of a steel ball of mass 1 kilogram. Weight of the body equals to mass into acceleration due to gravity. We already know that weight equals to mass into acceleration due to gravity. Here mass is 1 kilogram and the value of G is 9.8 meter per second square. So weight of 1 kilogram of steel ball equals to 1 multiplied by 9.8 Newton is equal to 9.8 Newton. So the weight of a steel ball of mass 1 kg is 9.8 Newton. Let's solve this question. Give example of when your weight is 0. Here we have to give an example of when our body is 0. The weight of our body equals to m into g, where m is the mass of our body and g is the acceleration due to gravity of Earth. We know the value of g, that is 9.8 meter per second square, but g at the center of the Earth equals to 0. But acceleration due to gravity at the center of the Earth is equals to 0. Weight of our body at the center of the Earth equals to m into g. In the place of g, we have to write 0. So m multiplied by 0 equals to 0. So weight of a person is 0 at the center of the Earth. So this was the difference between mass and weight. I hope these concepts are clear for you. What do weighing machines measure for, or what do they tell you? Is it mass or is it weight? After watching this video, I think there is no more confusion regarding this concept.